Hi, 8th grade. So today we're going to be going over some problems from the MLQ yesterday, just to make sure that we're all understanding it. The problem that we're going over today is one of the problems that we struggled with the most on the MLQ. It was one of the toughest problems. Shout out to Ziamara in Princeton, who got the most points on this question, and then shout out to Harvard for having the highest benchmark scores out of the three classes. You guys are doing awesome. Okay, so looking at this first problem, it says use the information below to solve parts A through C. The planet Neptune is about 4,500,000,000 meters from the sun, and Earth is about 150 billion kilometers, or 150 million, sorry, and the first one was 4,500,000,000. All right, so the part A says write the distance from Neptune to the sun in scientific notation. When we're reading these problems, I want to make sure that we're annotating because a lot of the issues we were having was just not doing the right thing. This first question was a pretty easy question, and the only mistake that people were making was not doing the right thing, not answering the right question. So we have 4,500,000,000, and we have to write it in scientific notation. So if you remember our two rules of scientific notation, the first rule is that your front number needs to be between what two numbers? Yeah, 1 and 9. So where can I put the decimal in this problem so that it's between 1 and 9? Right, I give it my decimal right here. So now my number is 4 and 5/10. All these zeros behind the last number don't matter. All right, so how many times did I move my decimal? Where did my decimal start in this problem? It started at the end, so I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 4 and 5/10 times 10 to the 9. In Princeton, what I saw a lot was two things. That some people were putting the decimal here instead, so that your front number was 45. What's wrong with that? Right, that's too big. Your front number needs to be between 1 and 9. And the other thing I saw was that people were doing the work exactly perfectly, looking exactly like this, but when you went back, you had counted the number of spaces wrong. I saw some 8s, I saw some 7s. That's just a little silly mistake that can be easily fixed by checking our work. So make sure we're checking our work on these tests. For part B, now we are finding how many more kilometers from the sun is Neptune than the Earth. We can do this two ways. We can subtract using scientific notation, or we can just subtract normally. So if I'm just subtracting normally, I would have 4,500,000,000 minus 150 million. Why am I subtracting and not dividing? I'm subtracting and not dividing because it says how much more or how many more. So we want to know what is the difference between these two numbers. How much bigger is this one than this one? So when I subtract, all my zeros stay the same. 0 minus 0 is 0. Can I do 0 minus 5? No, I need to borrow, make this a 4, make this a 10, 5, 3, 4. So you'll get 4,350,000,000. The biggest mistake I saw in this one was either not doing subtraction or just lining up the zeros wrong. So people were adding an extra 0. I even saw some people trying to subtract 4 billion from 150 million, so flipping the number so that the smaller number was on top. Your bigger numbers in subtraction always needs to be on top in a problem like this because you're trying to find how many more Neptune is than the Earth. You could also have done this with scientific notation. If you had done it with scientific notation, it would have been 4.5 times 10 to the 9th minus 1.5 times 10 to the 8th. Make this bigger, make this smaller. 10 to the 9, 0.15, 1500ths, and then you could have done it this way. And then you would end up with the same answer. And that works just as well. All right, moving on to part C, which was the trickiest part. Part C says the mass of the Earth is about 1 in 8,981 10,000ths times 10 to the 24th power kilograms. Use estimation to determine how many times greater the mass of Jupiter is than the mass of the Earth. Show or explain how you found your answer. All right, so Jupiter is, or the Earth is 1.8981 times 10 to the 24th. Is that right? Yeah, and then the mass of Jupiter is 5.9722 times 10 to the 27th. All right. So we know the mass of the Earth and the mass of Jupiter. We want to know how many times greater is the mass of Jupiter. What operation am I going to be using? I'm going to be using division because it says how many times greater. Think about it in terms of numbers you understand if this is giving you trouble. If I say how many times greater is 16 than 2, how many times greater means what do we have to multiply 2 by to get to 16? How many times do we have to multiply 2 to get to 16? If I say how much greater is 16 than 2, that's saying what's the difference. On a number line, how far would you have to travel? So if you're having trouble thinking of it with these numbers, substitute in numbers that you know and are easy to work with into the problem and see if it makes sense then. But so now I have Earth and Jupiter, and I want to know how many times greater Jupiter is. So I'm going to divide. Which one will go on top? Which one is bigger? Right, Jupiter is bigger. So I'm going to put Jupiter on top. And then my denominator will be 1.8981 times 10 to the 24th. Am I finding an exact number or am I finding an estimate? I'm going to be finding an estimate because it says use estimation to determine about how many times. So I can divide these two numbers, but I don't need to divide them. I can round them and figure out about how many times greater one is than the other. So 5 and 972 hundredths is about equal to 6. 1 and 898 thousandths is about equal to 2. So if I substitute in 6 and 2, this problem is now really easy to solve because I just do my numbers first. 6 divided by 2 is 3, and then I do my tens. When I am dividing with the same base, what do I do with my exponents? I subtract them, so it'll be 10 cubed, which can also be written as 3,000. So that was the answer to part C. All right, go ahead and try the practice problems on the back if you still have time. Good luck.